let's continue the talk on equilibrium. So now we're going to discuss what the saccule and the utricle does, what each one does. Get the proper tense here. So again, here are your canals, there. And in here in the vestibule, you have an upper chamber and the lower chamber, okay? The upper chamber again is called the utricle. The lower one is called the saccule. So the utricle's job is to detect movements linearly or at a movement that's being done horizontally. Like driving the car, going forward, backwards. That movement that's being done horizontally is detected by the utricle, while the saccule will detect movements going this way, up and down, like doing this movements, or in an elevator, for example, or jumping up and down. So that's vertical movements. They're both still non-angular. They're linear movements. Just one's going this way, one's going this way. So let's see how these work. So in these structures, you have an area. Again, we find hair cells. So in the hair cells, we have it. Let me erase a little bit for some space on my small whiteboard. So here you have, again, the hair cell. Hair cell. Hair cell. Okay. And these hair cells are contained in a structure called the macula. And these hair cells, of course, have the graded cilia on them as before. It's all the same case for both hearing and balance. They all use hair cells with graded cilia. And the cilia now is stuck in a gel. There's an overlying gel on them. Okay? That gel, what we call that gel, is I forgot what it's called right now, but then on top of the gel, you have seated on top of it are your calcium carbonate rocks called the otoliths that sit on top of the gel. Okay, it's called a gel for now. And again, so when you move the head like this, as you move the head, the rocks will weigh down on the gel to drag the cilia. So if you're moving this way, they will drag this way. And if you're going this way, they drag that way. Okay, so if you're going this way, they drag that way. If you're going this way, they drag that way. And the idea is once you bend the cilia, again, it opens up channels to let ions flow in to then trigger action potentials in the associated sensory neurons. So let's see how that works. Here we go now. Again, we're going to erase some space. But it's the same idea as before, where at rest, you're at rest. If the cilia is straight up and down like this, then it fires at a basal level. 1, 2, 3, 4. That's a basal firing. If the cilia gets bent during movement, such that they bend towards the tall one, like so, more gates open, and it fires a lot faster. And if the cilia is bent the other way, like so, away from the tall one, again, it fires less or not at all. So the brain knows where you're going, what the head is doing based on how these cells are firing. Okay? Now, once these neurons fire, they must travel up to the cortex where it's perceived. And so the typical 3-neuron pathway for equilibrium is this. So you have your first neurons will travel from, the canals or the vestibule. They will travel through nerve number 8, your vestibulocochlear nerve, and there were snaps in the vestibular nuclei in your pons. And then the second neuron will go from there to snaps in the thalamus. And the third neuron goes up to end in your vestibular cortex, which is located in the parietal lobe. And there you have it. Once it gets up to here, then you are aware of it, all right? So please note for me the pathway of the vestibular sense. Okay, let's pause there. We'll pause there.